Hello everyone and welcome back. In this video, we are going to learn how to write a signaling server. But before we start, if you know how to write a Node.js server and you just want to download the source, I'll put the GitHub link inside the description of this video. But if you do not know how to write a Node.js server or you want to learn, just go with me and write your code. So, there are so many frameworks, but I choose Node.js. Okay, before start writing codes, we need some tools. The first thing that you need is Node.js. To download Node.js, you just write download Node.js inside Google, go to the website and choose your operation system and just download. After downloading, you just click next and that's it. And the next thing that you need is an IDE. I choose Visual Studio Code as most of developers do. So to do that, just write download Visual Studio Code and open the official website and choose your operation system and download this. So I've done it before and now you just need to install it. Just click next and that's all. Pretty straightforward. You'll wait for installation to finish and open the Visual Studio Code. I use the dark theme. Next session, next, and markdown. Okay, I'm going to create a new folder. It's called WebRTC server and open the folder through my ID. Okay, I'm gonna maximize it. And after that, I'll open the terminal inside it. To start a Node.js application, you just write npm init. So after that, it asks you a package name. I press enter for default, index.js, okay, and everything enter. That's good. Okay. So we have the package.json. Right now we need two dependencies to create our server. First is WebSocket. I'm going to write npm install WebSocket just like that. And the next dependency is nodemon. Alright, npm install nodemon --dev. Nodemon is just a tool to make development easier. So whenever you save your code, it just restarted the server, so you don't have to start your server again and again. So all you need is WebSocket. Okay, so we're good to go. So here I'm going to create a new file called index.js, which is our main server. So we will create an HTTP server using HTTP. And after that, we'll create a socket object from WebSocket.server. And I'm going to create a server instance from HTTP object. .create server. And after that, I'll start the server passing the port 3000. And whenever it started, I'm going to log server started on port 3000. Okay. Right now, I'll go back to my package.json and create a script. I'll start and the value is going to be nodemon index.js. I'll save it and run it. So npm start. You see our server started on port 3000. Okay. So right now I'll instantiate my WebSocket. WebSocket is equal to new socket, which I've created here before, and as the configuration I'll pass HTTP server and give server to it. I'll add some listeners like this on request and give the request as a parameter to it. Okay, so I'll have a connection which is the user connection after all accepted. So I want to log the connection if user is accepted. So to test that, first you should save the codes that you have changed, and after that you can open your Chrome and search for WebSocket add-on. So the first link, and add this extension to your Chrome. So after that, open the WebSocket and write localhost 3000. Press open. You'll see the connection is made and it's all the information about your connection. Okay, so let's move forward. So next thing that you need is we are going to add listener on our connection, and whenever a user sends a message, we'll get that like this using on event listener and get the message as an argument. So we want to parse it using JSON. So my data is going to be JSON.parse message UTF-8 data. So whenever a message is received, I'm going to log it like this. I'll save it. I'll open the WebSocket client, localhost 3000, open the connection and send the request something like name equal to method. It's going to be a JSON object. As you can see, it's our parsed data. Okay, right now we are ready to get the data from the client. So whenever we want to send a data from our client, we'll decide what is going to be the data type. So something like this. Maybe it's store user. And if we send this, our socket server will realize that which type is it and decide to what to do with our message. So we'll start a switch of data.type. So the first case is going to be store user. So whenever we receive that comment or that signal, we want to get our user model and save it inside our WebSocket. To store the user, we need to create an array to hold the users. So I'll create a const of users is equal to an empty array. And I'll create a function called findUser, and as an argument I'll pass a username to it, and the function is going to iterate through our users array and find the specific user with the username that we are giving to. So to do that, I'll write a for loop I less than users.length and I plus plus. So we'll check if our users at position of I dot name is equal to username that we are giving it. Then I want to return users at index of I. So we'll go back up here. After receiving data, we want to get our user. So find user with the data.name. This name is the username that we are giving it to our server. So you want to check if our user is not null. Then we realize that our user exists. So you want to notify our client that this user exists. So we'll send through its connection a JSON object. So I'll stringify that user already exists, and I want to return from this case. So if the user does not exist, I'll add this user to my user array. So I'll create a new object of new user is equal to a JSON object of name of data.name, and I'll also save the connection of the user using keyword of con and give the connection value to it, so I can send the data to its connection later. So after that, I'll push my new user inside my array. So let's check the server. Localhost 3000. I'll connect. Let me extend this. I'll create an object of type. It's going to be store user, and the name is going to be massive. So if I send it once, it's going to store it. If I send it twice, it says the user already exists. So we successfully added our user to the user array. After that, we need a way to realize when a user is disconnected and remove it from our users array. So I'll add some other listeners called connection.onClose. It wants a callback, so I just pass an empty callback to it. So we want to iterate through a user array and get user from each iterate and check if our user.con is equal to the connection that we are using right now. It means that this user is disconnected. So we want to drop that user from our array. So I'll use this splice and delete one from our array. Okay, so if you want to check it, let's close it and open it again, send a message, send it twice, it says it already exists. But once we close it, after we open it again, the user is already removed, so we can store it back again. Okay, works fine. Right now, let me clear all of these useless logs. Okay, so let's go back to our switch case and check the next case, which is start the call. So I'll write start call. So I'll find the user that we want to call using findUser, and the username is going to be data.target. So whenever you want to create a call, you pass the target to the signal that you're sending to the server. So we'll check if user to call is valid. We want to send a feedback to the user that is trying to make a call. So I'll use connection.send a JSON object of type call response. As the data, I'll send user is ready for call, and else, which means user is not ready for the call, I'll send another message to our client of a type of call response, and the data is going to be user is not online. So let's test this one. I'm going to open it again. So we need to store the user first, and after that I want to use this start call command, and the target is going to be the user that we want to call. For example, let's say Ellie. Let's see what the response is. It says user is not online, but if I pass my name Masood, you'll see user is ready for the call. So the next case is going to be create offer. As always, first thing we need to find the target user, like user to receive offer is equal to find user data.target. So we'll check if the user already exists. then we want to continue. So we use the user to receive connection and send a JSON object. The type is going to be offer received, and the name is going to be data.name, and the data itself is going to be data.data.sdp, and the next case is going to be create answer. So as usual, we'll find user to receive answer is equal to find user with the target's name, and check if user to receive answer is valid. So we want to continue and send him the data using its connection. We'll send a JSON object like this, and the type is going to be answer received. The name is going to be data.name, which is our sender, and the data is going to be data.data.scp. So if you don't know what's going on here, don't worry, I'll show you when we get to the creating offer or creating answer. The next case is ICE candidate. So we'll find user to receive ICE candidate is equal to find user data.target user to receive ICE candidate is valid. We'll continue and send a JSON object like this. The type is going to be ICE candidate. The name of the sender is going to be data.name, and the data itself is going to be an other object. So the SDP mline index is going to be data.data.stp mline index. SDP mid is going to be data.data.stp mid, and the SDP candidate is going to be data.data.stp candidate. So that's all we need to do for our signaling server. Let me explain to you one more time that what happens here. First, we need to store the user to our array of socket server. So we check if our user exists, we return from the function. If it does not, we'll save the user and its connection inside it. So after a user starts a call or tries to start a call, we'll find the target or the opponent that we are going to call, and if it's not null, we will send the user is online and ready for connect, and if it is null, we will say the user is not online. So after the user gets a response that the target is online, so it creates its own offer. So it finds the target using the findUser method and will send the data that first user is trying to call you. So we offer him a JSON object with the name of the caller and the type of offer received and the data of our SDP or session description. And if he accepts, then we'll have a create answer condition here. So the second user creates an offer, an answer offer, and gives it back to the first user using this create answer. So it sends its own SCP using the name, which is the second user, and answer received. So they exchange their session description. After that, they both can exchange their ICE candidate. So they found each other and sent their data and set it inside their connection. So that's all you need to know for signaling server.